Welcome to Module 2. We're exploring linear and exponential functions in this model. In Lesson 1, this task asks you to connect your experience with geometric sequences and exponential functions to develop general methods for expressing equivalent forms of exponential products, quotients, and powers. The essential question for Task 1 is, what are the general methods for re-expressing equivalent expressions involving exponents? Let's get started. In Unit 1, we explored many examples of geometric sequences such as the one shown below. A of n equals a of n minus 1 times 2, where a of 1 equals 5. If this is new notation to you, this is exactly the same as f of n is equal to f of n minus 1 times 2, where f of 1 equals 5. Our current output is equal to our previous output times 2, and the first output is 5. Question 1 says, show how you would use this recursive formula to determine the 9th term in the sequence. Remember that recursive formulas look down a table. They describe a relationship between outputs. On the left-hand side of our tables, we have n, and on the right-hand side, we have f of n. N is our input, f of n is our output. We've got to determine the 9th term. Using our recursive formula, we know that the current output is equal to the previous output times 2. So we'll take our first output, multiply by 2, and we'll get 10. Then multiply by 2 again, and we'll get 20. We continue multiplying by 2 to complete our table. 40, 80, 160, 320, 640, and 1,280. Using our recursive sequence, we figured out that f of 9 is equal to 1,280. Now we're asked to write the explicit formula. If we look at our table and expand it, our explicit formula should contain the starting value and our rate. I'm going to start with 210. That's 5 times 2. 20 is 5 times 4, which is equal to 5 times 2 squared. 40 is 5 times 8, which is equal to 5 times 2 to the 3rd power. 80 is 5 times 16, which is equal to 5 times 2 to the 4th power. Now I can tell that I'm rewriting my outputs in terms of 5 and 2. So I can go back to my input of 1. That's 5 times 1, or 5 times 2 to the 0 power. I have enough information now to determine what equation I would use if I had an nth term. Looking at the pattern here, I can see that I'm multiplying 5 times 2 to the power of n minus 1. So for my explicit formula, f of n equals 5 times 2 to the power of n minus 1. On your own, answer the question number 3. Which form is more efficient for determining the 9th term in the sequence? Explain why you feel that way. Then begin questions 4, 5, and 6 and bring them to class so we can start our discussion.